Hey guys, here we are for chapter 12.2. Today we're going to talk about food production. We're going to cover a lot here, so hang on, and here we go. As my dad would say, here come the meat and potatoes of it, since it really is. Now, we're going to talk early on about kind of industrialized agriculture and then traditional agriculture. Industrial agriculture tends to be high output, and traditional agriculture tends to be lower output, less crops per acre, if you will. But let's take a look. There are three systems that produce most of our food. Croplands. Now this is where we're growing the grains, mainly rice, wheat, and corn. Then we have rangelands. This is where we are putting the animals out to pasture, if you will, to get food, and fisheries. These are our three big things. Croplands for grains, rangelands for animals, and fisheries, obviously dealing with fish. We have had a lot of important technological advances over the years. The big three, if you will: irrigation, synthetic fertilizers, and pesticides. Water for the plants, fertilizer for the plants to grow, and pesticides to keep the bugs from eating it once it is growing. If you've ever done a little bit of home gardening, you know any one of those falls by the wayside and it doesn't grow very well. Let's start off by talking about industrialized agriculture. Now, this is your big operation, tractors, the whole 9 yards. This requires heavy equipment and large amounts of financial capital. You don't just start farming on an industrial scale willy-nilly. All the equipment that you have to buy, you got to buy the seeds, preparing the land. So there's a large amount of money that has to be laid out at the beginning. It relies on fossil fuels for our tractors to run. We need to water. We've got to make sure we can water on a schedule, so we got to set up irrigation of some shape, form, or fashion. Typically, these are using inorganic fertilizers and pesticides. Just chemicals that you can buy and throw out onto the land to either add the nutrients the soil needs or get rid of the bugs that are wanting to come and eat it. Industrialized agriculture also tends to be monocropping. We call it monoculture. It's just a single crop. I'm going to grow wheat here. I'm going to grow corn here. I'm going to grow barley there. It tends to be single crops. The major goal of industrialized agriculture is to increase crop yield. I want to produce more kilograms of food per square kilometer. I want to increase the crop yield. That's what industrialized agriculture is all about. Yeah, they're wanting to feed people, but it's a business. We also have what we call plantation agriculture, and these are ones that are growing cash crops. The industrialized agriculture tends to be in the developed world, highly industrialized world. The plantation agriculture we tend to find in the developing or the less developed country. And what they're doing in a plantation is they're raising cash crops. They're growing palm oil, soy, something that they know they can export. And a lot of these plantation crops are doing just that. They are growing it to export. It's just after the finances. They're not trying to really feed people there. They're making money. Organic agriculture. So we have this industrialized, and then let's talk about organic agriculture. This has really grown pretty big in the last 20, 30 years. It's been around before that. We've just seen a big uptick in organic agriculture. Now, if it's organic, technically speaking, and I'm not going to get around like what the FDA calls this or that. There are all sorts of little weird things they play around with labeling. But organic agriculture, this means the crops are grown without synthetic pesticides or fertilizers, and they're using no genetically engineered seed varieties. Animals have to be raised with 100% organic feed, which means there can be no antibodies or growth hormone tossed into the feed. So yes, If it is not organic, then they're using chemical fertilizers and chemical pesticides. If it's organic, they may be using fertilizer, but they're going to use things like cow manure, mulch, something that's natural as opposed to just chemical in nature. They can still use pesticides. They can put ladybugs out in the field, plant plants that deter. So it's not that they don't use fertilizer or they don't use any type of pesticides. They're using natural pesticides, natural fertilizer. It is more labor intensive than the commercially produced or this industrialized produced, so it then winds up costing more. A lot of people like it because they know it is definitely more natural, but there is a cost involved with it. Once again, it's just more labor intensive. I throw this chart up and you can take a look at sort of the differences between them. Industrial, synthetic, and organic uses conventional and genetically modified crops. It tends to be export oriented. We're growing a lot of food to export it around. It uses antibiotics and growth hormones to help speed up the process and make sure nothing's getting sick. Once again, they want to make sure more things make it to market. Organic, however, is emphasizing prevention of soil erosion, not having as much, they're putting the plants back in, we're not losing, the soil's not exposed as much as in traditional, so we get less erosion. There's no genetically modified. They tend to do crop rotations and use biological pest control. It tends to be more regional or locally oriented. They're looking at selling in this area as opposed to major exports. You can kind of look at that chart and get a feel for the difference between the two, and both have their benefits. Now, starting in the 50s, it was really in the 70s that it tended to take off. In 1950, we have what we call the Green Revolution. It sort of came in two phases. We'll talk about the first Green Revolution and the second Green Revolution. First Green Revolution. This is where farmers went from typically growing a whole bunch of things out. Had a little area of corn here, a little area of potatoes here, little things of green beans here, and they were growing mainly for their family in a little surrounding area. And they started monocultures, growing one singular crop and focusing on getting high yield crop. If I just focus on corn, I can get better at growing corn. If I just focus on wheat, I can get more wheat growing out. And the big crops were rice, wheat, and corn. They used large amounts of fertilizers to make sure they got plenty of nutrients in the soil, heavy use of pesticides to make sure nothing was eating it, and increase the amount of water, irrigation. By doing that, they could put the plants closer together. They didn't have to go weed. They were using herbicides, pesticides to do that. And then a lot of times they could start doing some multiple croppings. In other words, they could get more than one growing season. Instead of just getting one growing season, they could get 2 or 3, depending on where you live for the temperature. Up to the ante, more fertilizers, pesticides, tighter crops, and getting more growing seasons in. So they're producing more food per square kilometer on their land. The second Green Revolution came about later, a little after the 70s. This is where we started using some of our more genetically modified. Now, a lot of these we had just been doing crossbreeding, not gene editing, but we were using fast-growing varieties of rice and wheat. So we've been working with some crossbreeding. We had some that grew quicker, so this allowed us to do that multiple cropping. We could get more seasons of growth because they grew and got to maturity faster. And our world grain production grew dramatically between the 50s and the 2010s, if you will. On one side, we see the grain population just overall, and then per capita. Note the grain production per capita is going up and down. More people. Just over the time, our crop production has gone up and up. But per capita, it depends because population increases, and as the population's been increasing, food production's done a pretty good job of keeping up, but not always. Industrialized food production in the United States as a case study. Just looking at a case study specifically here. In the United States, it is agribusiness. Typically, a few multinational corporations control the growing, processes, distribution, and sale of foods. You go out there and even name brands, there's a handful of name brands, but it's only one farming industry, DeKalb or something, which is growing most of the corn, or another company is growing most of this. Major multi-corporations are involved in managing the business, and the food production has become very efficient. Americans, on average, spend about 9% of our income on food. That's a very small amount. A lot of people are spending 50 to 60% of their income on food. So we've gotten production down to a science. We produce it cheaper, a lot of it, and Americans in a fairly wealthy country are only spending about 9% of our annual budget on food. Of course, the actual costs are actually much higher. We talk about this full cost pricing. Well, when it comes to food, there's some hidden costs. Subsidies are paid by the government to keep farms in, cotton and wheat and corn specifically. So subsidies are paid to keep them in, that keeps the cost down. The pollution and the environmental degradation that happens with a lot of this monoculture, monocropping, winds up costing us on the back end and taxes. So it's cheaper here, but once again, not surprisingly, especially when there's any kind of subsidies involved, there's some hidden costs that we're paying on the back end instead of paying for it on the front end. Let's talk genetic revolutions. This is part of the aspect. Early on, the first gene revolution was crossbreeding. This is going back into the 50s. We started crossbreeding through artificial selection. Now, we've been crossbreeding through artificial selection. The Native American Indians were crossbreeding. The original corn was the size of my pinky. And through crossbreeding, we got it bigger and more ears per plant. This is a slow process, but we do get amazing results. Original tomatoes are like this big, but we find a tasty tomato and we cross it with a larger tomato, and through a few generations of crossbreeding, we can wind up with a large, tasty tomato. So crossbreeding has had phenomenal results, but it does take time. 15 to 20 years to get a new viable plant to market, if you will. If I'm really going to create this new variety of tomato, which is larger and tastes just as good as something else, or is meatier, what have you. It's a slow process. Genetic engineering, which gets us into that sort of second green revolution, if you will, is where we're altering an organism's DNA. We genetically modify the organisms with transgenic organisms. We take a gene out of one plant and we insert it into another to get a particular quality that we like, to make it bigger, to make it sweeter, to make it able to grow with its own pesticides in it, what have you. The latest one is the CRISPR. Now, if you're in my class, we watched a video on this earlier in the year, but the CRISPR is a gene editing technique that allows us to change the genes of the actual organism itself and very quickly. So crossbreeding, we can get phenomenal results, but it's a very slow process. Especially when we get to today's technology using the CRISPR, might take 15 years to get a new product to market by by crossbreeding. We can get something to market in a matter of months, 6 months to say a year with the CRISPR. It's a lot cheaper in the long run. Of course, there's always potential downsides. We don't know everything really about the gene editing and splicing. So when we do this, and once something is out there in the world, then its genes are out there in the world because cross-pollination occurs. We can't keep it from happening. The wind blows the pollen over here. The pollen from my genetically modified organism gets into the pollen of a normal, not genetically, and then the offspring will have genes of both. So once something is out there in the world, it's impossible to completely contain it. Now let's talk about meat consumption. That's all been grain so far, what we're doing with the grain. The meat production industry has increased more than six-fold, 6 times between 1950 and 2018, if you will, at the writing of this particular book. Pork, poultry, pig, chicken, cow, okay? Pork, poultry, beef. We changed the names so we don't really think of the animal, but that's what it is. Pork for pig, poultry for bird, beef for cow. And there's been an increased demand for grain because we have to feed the cows, right? About half of what we grow grain-wise goes for immediate consumption, and about half of what is grown around the world for grain goes to feeding meat, animals of some kind. There's a greater reliance on the grain imports for this. We're having to import grain to feed our animals and et cetera. And China is one of the really big. They have a lot of people, not as much arable land, and China is literally buying land in other countries so that they can grow grain to import to feed their meat. Now, about half of the world's meat is raised on rangeland. You know, it's out in the pasture. That's the cow out there in the grass. The other half are in factory farm systems, what we call CAFOs, concentrated animal feeding operations. You can take a look at the picture here. The first one you're looking at is a cattle farm. So they might be out on the rangeland for a while, but a few months before we're really going to take them to market, we fatten them up and they go into these feeding operations. So they're all in, they can't move around as much, so they're not burning off any of the extra calories, and we're fattening the calf, ready for the slaughter. Second picture you're looking at is a poultry or a chicken farm. So in a chicken farm, we'll have like 100,000 chickens in one operation. So when we talk about these concentrated animal feeding operations, this is what we're referring to. All the animals packed in really close. We're feeding them grain specifically so they can eat, fatten up quickly so we can get them to market. Taking us to fish and shellfish production. Other end of our large protein. Cow, bird, chicken, cow, pig, bird, chicken being a lot of it, but anything that's poultry, bird related, produces a lot of our meat. The other end of it is fisheries. Now there's been a concentration of particular species that are suitable for harvesting. In other words, we only go after certain species of fish. Not every fish out there is actually good to eat and or tasty or has enough meat on it to make it worth the effort or the time. So we tend to concentrate on the ones that we are after, whether it's Chilean sea bass, mackerel, salmon, tuna, what have you. Now in the ocean currently, 61% of the ocean is being harvested at full capacity, and about 29% of it is in the term of being overfished. 90% of our ocean out there is at full capacity or beyond what we're able to catch. And when you look at the numbers, they have completely leveled off on our fish catching, because no matter what the technology, the fish aren't there. We have pretty much capped out what we're able to go catch in the ocean. And if we overfish, the population drops, obviously. A lot of our fish for consumption, or fish and shellfish, comes from aquaculture, fish farms, if you will. 88% of all the fish farming is actually done in Asia. I think a full 60% in China alone. But Asia makes up most of our fish farming. The amount of fish and shellfish that are produced globally through aquaculture increased 12-fold just from 1980 to 2014. So this shellfish and fish production through the aquaculture has just grown tremendously. Once again, 12-fold just in the past like 40 years or so. The wild catch level has leveled off and declined, I think since about 96. We'll take a look at a chart here in a minute. And the farming of meat-eating species are also, so we have fish. Now a lot of fish out there, catfish, tilapia, carp, to name a few, they eat algae or plant matter. So in the farms with that, they can eat the algae, plant matter and grow, but others like salmon and shrimp actually eat protein. They eat other fish or other organisms. And these are normally fed fish meal or fish oil that's produced from other fish. So some of those fish out in the ocean that you and I may not eat, we're catching them, grinding them up to feed into the salmon and shellfish. So some fish are actually environmentally more friendly than others. Now the picture up here is of a fish farm in Thailand, area in Thailand. These are specifically growing shrimp. So you put them out in little patties, you can put things underneath, you throw the feed in and you kind of pull the nets up, harvest. But this way we know exactly which one to harvest. And you know, pond 1 might have the babies, pond 2 are juveniles, pond 3 are the mature, and pond 4 are the ones ready to harvest. And you harvest and shift around, start with a new batch. So you can kind of run through a constant harvest of them. The chart that we're looking up here is the fish and shellfish production, if you will. Now you look at the wild catch, it was rising, but it has leveled off. Once again, yes, somewhere in the 90s, pretty much has leveled off because we're at maximum capacity. We're out there catching as many fish as we can to keep it sustainable. In some cases, we're going beyond that. But you see the aquaculture has really kicked and taken off, where the aquaculture is where we're getting a lot of our fish now, and it is also much more sustainable. Well, that takes us through our main productions, grains and meats, if you will, which will take us up next time. We're going to look at some of the environmental effects of our food production. Anyway, take care, guys. We'll see you next time.